The positive feedback, this time, the first example is about water vapor feedback. So how increasing water vapor intensified greenhouse effect, intensified global warming. So let's take a look. Initially, we have climate warming, right? In the photograph, you can see increase in warming. So what happened? We increase the atmospheric water vapor. Why? Because a higher temperature means more water is being evaporated. So if you think about the whole water cycle, water changes from liquid form to vapor form through higher temperature and evaporation. So a higher average temperature in the world means more atmospheric water vapor because more water evaporates from liquid to vapor. Then the next step, because water vapor is a kind of greenhouse gas, so it's going to trap or reflect the outgoing long-wave radiation. So we have something like the counter radiation, trapping the heat, trapping the radiation, going back to the land surface. So it increases the warming again. So you can see the final step is increased warming. And because we have increased warming, higher temperature, then more water is being evaporated. And as a result, we have more greenhouse gas in the atmosphere, and then intensify the greenhouse effect. And then we have higher temperature. So it's a never-ending feedback loop. So that's why we call it the positive feedback loop for higher temperature, more water vapor, and eventually higher temperature as well. Another example of positive feedback, the ice albedo feedback. So what does that mean? So initially, again, we have warming, higher temperature, but this time, instead of increasing evaporation, we have decreased snow and ice cover. Because of higher temperature, more ice and snow melt. Ice and snow from the polar region, from the alpine region. Let's say ice sheet, glacier, snow cap. So these snow cover is being reduced because of a higher temperature. And as a result, because the snow and ice has the highest albedo rate. Albedo means the reflection rate of land surface to the sunlight. So high albedo means more sunlight is reflected by a particular land surface. So it can be a forest cover, can be snow cap, can be tarmac of urban road, can be the sea surface. So different surface and materials have different albedo rate. So snow and ice has the highest because they are shiny, they are bright. As we have warming, less ice, less snow cover, then the albedo rate of the land surface is going to decrease overall because less ice cover. Let's say the ice melt, now it becomes soil, barren soil. So the slight change in the material and color of the land surface is going to reduce the albedo rate from ice to soil. So what does that mean? It means that we have less solar radiation being reflected to the outer space, and instead more solar radiation or insolation is being absorbed by the land surface. It means that we have higher average temperature in the planet. So a warmer temperature means more ice and snow is going to melt. And again, albedo rate decreases, then higher temperature as well. Then the final one is the negative feedback loop. So again, negative is you do something, you end up have less to do about it. So it's kind of like buffet. You go to buffet, the first few rounds, you carry a lot of food on your plate and you go back to the table and you start eating a lot. But after the first few rounds, you start getting full. So the next few rounds, you're not going to carry as much food from the buffet, right? So eventually, you're going to stop. You say, I'm full, I can't eat more. So that is kind of a negative feedback. So you do something more, end up causing you to do less about it. In the cloud radiation feedback, so this time it's a bit uncertain in the outcome, but I'll go through it. So initial change again, we have warming, higher temperature. Then higher temperature should naturally increase the amount of cloud. Why? Because just now we mentioned higher temperature means more water vapor in the atmosphere. And when we have more water vapor in the atmosphere, eventually they're going to cool and condense, because in the high altitude, the temperature is lower. So temperature lower means the air particles are going to cool down and condenses, become liquid again. So that's the process of condensation. It means that the cloud we see are actually water droplets combining together to form cloud. And that's why after raining, there's no cloud, because all the water droplets in the cloud have already fallen to the ground. So when we have more cloud, it's going to reflect more incoming solar radiation. So because it's like albedo, we just mentioned, the white surface of cloud is going to reflect incoming solar radiation, so reflect back to the outer space. When we have less solar radiation, so it's going to have less warming. In the cloudy days, it's less bright and the temperature is usually lower. But in days with good sunshine, there's no cloud, temperature tends to be higher because the insolation and the sunlight just penetrate through the atmosphere, hitting the ground directly. In cloudy days, lower temperature because the cloud reflects the insolation, reflects the sunlight. With more cloud this time, because of more water vapor, the temperature is going to decrease. So the outcome should be uncertain because, okay, now we have reduced warming. Does that mean we have less water vapor? But less water vapor means less cloud, that the temperature should increase again. In the macro scale, planetary scale, it's very difficult to calculate, and we don't have such an accurate calculation and measurement of the temperature. So far, the outcome is still uncertain.